Hi, so today we are going to um, learn the concept DFS. So we are doing graphs, and the first topic is like DFS. So most probably we will do a lot of question, not a lot of question, but we will try to understand what is DFS and how we apply the algorithm to DFS, and most probably one or two questions we will take today's lecture. So let's just start. Okay, so let's go to the pad one note. Okay, so 1 second. Okay, so what is DFS? Okay, so we are going to learn today is DFS. 1 second. DFS, as it names is depth first. Uh, what was the S stand for? Depth first search. Okay, okay. So let's say we have a graph like this: 0, 1, 2, 3. This is 4, 5, 6. This is 7. So DFS is a graph traversal technique. So in a graph traversal technique, we have to print nodes like uh, in a way. Let's say you can print 4, 0, 3, 7. So in any way, you have to print the nodes. So we have one traversal technique is a DFS. In DFS, what happens is that we will print every node in a depth fashion. Let's say this is the starting node we have. This is the starting node we have. Let's say, okay, 0 is the starting node. So let's print that 0 first. So we will write the output over here. So first of all, we will print 0. This is the node. Now we will take well, now we will take its neighbors node. As you can see, there are three neighbors node: this one, this one, this, and this. So you can pick either of them, doesn't matter. Let's say we will pick 4 first, and we will mark it as printed. Okay, so we'll print this like 0 and 4. Now there is no neighbors node. There is no neighbor node. So we will go back or backtrack. So we are basically use recursion in this algorithm. So you should know the recursion, and if you don't know, it's if you know little bit, it's fine. Uh, Now let's proceed. There is no neighbor node, so we will backtrack and we will come back to the this node again. Now let's see how many nodes its neighbor node has, which is not visited. Uh, I'm marking yellow, which is yellow with those nodes who has already visited. Now, as you can see, there are two nodes who is visited and printed. Okay, now we have three nodes. It's which is neighbor of its 0th node. So we will go one by one and print that node. So let's say we are going to this node and just mark it as a visited and print that node. So we will mark it as a visited and print this, put this node to the output. And now, as you can see, there is no node which is neighbor of it. So we will backtrack to the 0th node. Okay. Now, now we have only two nodes left, which is not visited, and it is the neighbor of the 0th node. 0th node is this. So we are at 0th node. This red is 0th node. Let's say this is the current node pointer, and the current node pointer is this. Okay. Now let's just go to 2 or 3. You can choose any of them. You can go to 3 first, then come back to 2. It doesn't matter. So let's go to 2 and mark it as a visited. This is 2, mark it visited, and put this node to the output. So this is the output. Now go to its neighbor. What are the neighbors? Its neighbors are this. Let me erase first this green line. Okay. Now for this node, let me once again erase this thing as well. And we are at this node. So red color is marking to the current node. We are at the node 2. Now, if you find its neighbor's node, its neighbor, what is its neighbor's node? This is the neighbor node and this is the neighbor node. Now, I already told you that we have to visit only that node which is not visited. As you can see, this is marked as in yellow color, so we already visited it. So we don't need to go again. Now let's go to the 5 and mark it as a visited and put that node into the output. So this is the thing we will print. Now our current node is this 5. Now go to its all neighbors and whatever not visited just put into the output, and that's it. So its neighbor node is 2 and 6. Let's just 2 is already visited, so just mark the 6 node as a visited. This is node visited and put that node into the output. Okay. Now as you can see, we already print all the things like in the depth fashion. Like you'll go deeper first, then you'll come back. Like you are here now. Current node is here. There is no neighbors node, so we will backtrack or go back. Again you will find the node from 5. There is no neighbor node, so you will go back. There is no neighbor node for 2. You go back again. Now you are at 0th node, so the current node is this. Let me erase all the arrows. Okay, now your current node is this, and if you find its neighbor node which is not visited, which is 3, you'll go to 3 and just mark it as a visited and put the value of 3 is on the output. And now your current pointer or current node is 3. Now 3 has only one neighbor node which is 7, or it is not visited. So we will just mark it 7 as a visited and put that value into output, and my current node is this now. So this is my current node, and as you can see there is no neighbor node, so we will backtrack or go back to the third node. Okay, now our current node is this. Okay, and as you can see all its neighbor node are visited. If there is, let's say if there is a node connected to this, let's say 9, so we'll go back like we came from the node 7, and now we will check for the node 3 if there is a neighbor node which is not visited. As you can see there is a node which is not visited. We will take this, we will go to this node, let's say erase this, and now the current node is this. Now this is visited, we will mark it visited, and the whatever the node is just put that node into the output, and the current node is 9. As you can see there is no node neighbor node left, so we'll go back to the parent node. This is the child node, this is the parent node. Okay, parent node, and for the parent node now our current is this. For the parent node there is no neighbor node left which is not visited, so we'll back again to the 0th node, and for the 0th node there is also no neighbor node which is not visited. So we are done, and this is the DFS traversal we have. Okay, so what is the difference between the DFS and BFS? I'll just quickly go through, like, just explain. We will have a detailed video on BFS, so don't worry about. I'll just uh, going through, like, what is the difference. I'm going to, let's say this is the node 0, 1, 2, 3, this is 4, 5, and this is 6. This is the graph we have. Now our starting point is this, like, let's say this is the starting point, and I'll go to and mark this and print this, like, let's say this is the output, and let me write over here is like this is the BFS, not in depth, but yeah, just uh, uh, just giving you idea how the BFS works so that you can relate them. Don't confuse between BFS and DFS. Just remember its word, like it has a depth, or if you Google it, like what is the full form of BFS, so it will say is breadth first search. I don't know what's the spelling of this, so it will be breadth first search. Breadth means going wider. First go wide, then go depth. I hope this makes sense. So we are at current node. What is the current node? Is this, okay, 0th node. Now we will go to each, like, each of its neighbor. First we will print, then we will go deeper. Like, if you choose this node, this is the neighbors. Let me zoom it. Okay, these four are the neighbors of 0th node. Now you'll go to each node first, print that node. Let's say uh, uh, let's say we are go to fourth node and print first and mark it visited, then go to its three second node, that is 3. We will print that thing and mark it as a visited, then we will go to its second node and print that node, sorry, uh, okay, this is 2. Now go to its first node, which is the neighbor of the 0th node, so we will mark it 1 as a visited and just write down on the output. So this is the way, like, uh, this is the node and it is neighbor, its neighbor is this, so we will print that first, then we will print, then you will go to, you will choose, like, I will go to this node, so you'll go to this node and explore or the its neighbor, then go to again depth, like it has, let's say you are a current node is this, you pick first this node, and now you will choose, like, what are the neighbors. It has only one neighbors, and we will just mark it as a visited. And let's say if it has a two neighbors, let's say 8, and it has a three neighbors, 9. Okay, so we will visit all its neighbor, then go deeper. Like if you have this as a 10, then first of all you will visit this thing, okay, you'll put into the output section, like 958, you'll go to this 958, and all the neighbors of 3 node, this current node is visited. Now you'll go to one of its node, one of its neighbor, and travels all its neighbors. Like if you'll go to 9, you'll just mark it 10 as a visited and put into the output. And if you don't get anything, just come back and see if there is other node which is not visited. No, then you will come back to the 3, and you have a 5 node, you have 8 node, just go wider. Okay, I hope this will make sense. I just don't care about BFS right now because we are learning DFS. Now, I think this is enough to know. Like, now let's go to the coding part, and uh, we will we will do some coding so that you can understand better. Okay, so I don't have any question included inside this to print the notes in a DFS manner, so I will search it. Most probably it will find only code or GFG, so let's do that. DFS algorithm question. Okay, so medium, it's problem list we have. Okay, so let's type GFG. Mm, okay, DFS graph problem. Okay, so given a connected undirected graph and 2D. Mm-mm. So we have to print, okay, 0, 1, 2, 3. Okay, we have to print this. Okay, let's just say, read the question carefully. I'll give you 1 second. You can use like read the question first and then not 1 second. I'll give you 2, 3 minutes. So I'm going to also read. So given a connected undirected graph containing V vertices represented by 2D adjacency list ADJ and vector, where each adjacency represents the list of vertices connected to I, perform the depth first search traversal starting from vertex 0, visiting vertex left to right, do traverse same order as the adjacency list. Okay, so okay, uh, let me once again, guys. Mm. So we have given this thing. Uh, Most probably, a lot of students confuse this thing like what is this given. So let me show you what is given. So we have given an adjacency list ADJ, which is the 2D array. So what it will show, it is representing graph. How? Let me show you. Uh, Let me take that question 2 3 2 3 1 and then 0 uh, 0 4 0 4 and 0 and 2. I think this is the reason. And if you do indexing, this is the 2D array, and if you do indexing, let's say this is 0 1 2 3 and 4. Okay, so the size of this vector, this adjacency list, shows there are that many number of nodes. Like in this case there are 4. The 4 is the size of this adjacency list, so there are 4. N equal to number of nodes. Okay, this is the representation. I have already upload the video. uh, in that video I have teach you that how to represent, what are the various way to represent the graph. So this is the graph representation concept I am teaching you again so that you can, it's just a learning starting phase, so I have to uh, repeat uh, until you understand. So just be careful. And the n is the number of n is the size of adjacency list. So in this case there is 4, so there are 4 nodes, 0 1 2 3 4, starting from 0 1 2 3 4. In the most cases the nodes are starting from the 0 1 2 3 4 or 1 2 3 4. Okay, this is in sequence manner. I don't see any question that starts from 2 3 4. So let's go and take all of those nodes. So what it says, like, this is the index, this is index. So At the 0th index, there are a vector which has the value 2, 3, 1. This means 0 is connected to 2, 3, and 1 in unordered fashion. That means we have a node 0, and this 0 is connected to node 2, node 3, and node 4. Okay, now if you go to index 1, 1 says node 1 is connected to 0. Node 1 is also connected to 0, so this is the node 1 which is connected to 0. Now if you go to index 2, now 2 says 2 is connected to 0, it is connected, and 2 is connected to 4, 2 is also connected to 4. So this is the case, and I think I am going correct. Okay, there is no 4. I am sorry, I am really sorry about that. Okay, so this is not 4. So let me start again. Sorry guys. So we have 0, 0. At the 0 index we are here. So 0 is connected to 2. This is 2 in undirected fashion. Like uh, what is the directed? Like uh, if says like 0 is connected to 2, that means this, and undirected, that means 2 is also connected to 0. So rather than uh, writing two arrows, so we will just use undirected, means undirected line like this one. Okay, let me erase this. Okay, this is undirected. 0 is connected to 2, and 0 is also connected to 3. This is 3. 0 is connected to 1. Okay, now we are at index 1. Index 1 says node 1 is connected to 0, so node 1 is connected to already 0. Okay, that means we already have don't worry about this, like they have separately do that. Like if you try to do like 0 is connected to 1, so you can make this as arrow. Now if you go to one index, it is connected to 0, so this arrow. So uh, they given as a directed graph, but you have to treat it as a undirected graph. So uh, to show this two arrows, I will just erase this thing and just make a undirected line over here, which shows there is 0 is connected to 1 or 1 is connected to 0. I hope you understand. Okay, now we are at index 2. Index 2, that means node 2 says I am connected to 0 and 4. So node 2 is already connected to 0. We are assuming this is undirected graph, so they have they have given as a directed graph. So 2 is connected to 0. Now 2 is connected to 4 also. So if you take this like this, okay, let's say this is the directed. Okay, don't confuse, this is undirected graph, and I'm just making sure at the end of the day, if you go to index 4, that means index node 4, these index are representing node. Okay, how they are connected, like if you go to 4 node, this is the node 4, and you see like 4 is connected to 2. Okay, 4 is connected to 2, that means 4 is connected to 2, the arrow goes like this, and if you combine this, they become undirected graph. That means you can go from 2 to 4 or 4 to 2 as well. So I'll just erase this thing, and undirected graph are marked without direction, so I'll just put the line in between 2 and 4. Okay, now let's go to the node 3. Node 3 says I am connected to 0, and 0 is also already connected, so only. So how we graph make is this. Okay, okay, so let's go now how we are going to print this. uh, this is like You can start with, okay, so the starting from vertex 0, so we have to start from the 0, from the 0. So I will mark the starting color as green. So this is the starting point. We have to start DFS from the here. Okay, what I will do is, like, I'll just go to this, I'll just print this, print zeroth node, and I will also take care, like I will create an array or a vector array. Let's say this is 0 1 2 3 and 4. Okay, now I will make the array of size the number of nodes we have. Like how many number of nodes we have? It's 4. So we will create an size of 4. What it says, like, is visited, is visited, is 0th node is visited, is 1th node is visited, is 2nd node is visited, is 3rd node is visited, is 4th node is visited. So I will mark like true or false here, true or false. Every cell I will mark true or false, true or false. True means the node is visited, false means the node is not visited. Okay, let me undo these things quickly. Okay, now we will starting from the 0th node, so we will mark it as a true. That means we already have visited, and just print that value. This is the print. Okay, let me erase from the here, and we will just print below. So we are going to print over here. Let's say this is the output, and we will print 0 first. Now we will go to its neighbor, all its neighbor, whatever. You can go either of the neighbors. There are three neighbors. What are the neighbors? This is the neighbor, this is the neighbor, and this is the neighbor. Three neighbors we have. We can go to any of the neighbors. Like let's say we will go to 2 and going to mark the second node to true. Initially all the nodes are going to be false because we haven't visited any of node. So we will mark initially false to every node. I'm not marking here, but in the program we are going to mark it. Okay, so don't worry about it. Okay, so we have marked node 2 as visited, and just print that node. uh, okay, now go to its neighbor. Like it has a neighbor, only one neighbor, so go to its neighbor and mark it visited, and mark it visited true. Mark it node 4 is visited, so we will just put 4 over here to output. Now go back, because there is no node, there is no neighbor node of 4, so we will go back to the 2 and ask for, is there any other node which is not visited, which is not visited. There is 4 neighbor. We are currently over here. There is one neighbor which is 4, and it has already visited. Is there any other node? No, we don't have any other node, so we will go back, and we are at the 0th node. Now we will ask, is there any other node which is not visited? 2 is already visited. This is already visited. We have 3 and 1 which is not visited. So we will go one by one and do the same process again. So I'm not going to do this because I have to write the code as well. Okay, so let's jump to the coding part. And yeah, so we have to create a what it says, a recursion function. So let's just create a recursion function. uh, it will be void. Okay, let's name it DFS, since there is also one DFS, but its parameter are different, but I will use DFS2. You can name it as a DFS because its parameter are different, so don't worry. So I will take node. We are starting what the current node we have. Okay, just stick with me. Don't worry if you don't understand the code part right now. Just give me 2 seconds because I'm just writing the parameters. So in Node, what I will need is adjacency graph. Okay, let me. Okay, what we need other than we need a visited is visited. So it would be vector of bull. Uh, it mark it visited visited is visited is visited. Okay, I think this much of parameters I need. So let's create what are the number of nodes we have. I already tell you that whatever the size of adjacency list, that many number of nodes we have. So we will create that much of size of array for visited. Vector of bull is visited of size n, or initially we will mark all of nodes are unvisited, so we will mark it false. Okay, after marking it false, so this is the function. Like if you pass two parameters, first parameter is take the size of the array, and the second what are the initial value you filled for the all the cell. You can do this thing like go to each element, each index, like n I plus plus, and is visited of I equal to false. You can do this thing as well, but use this thing because it's very easy. You can just pass the false value to the all over the cell. Okay, so we will just create an answer variable or result variable. You can say answer of size n. No, not mention the size initially. Okay, so answer, and we will pass it to the this thing where we want to return the vector. As you can see, in that vector we have to print the DFS traversal. So we will just store into that. We will just store the whatever the output come from the DFS traversal. So this would be like vector of int and answer. Okay, so we will call DFS to starting node would be 0, and adjacency list pass we have to pass is visited, we have to pass, and we have to pass answer, and at last we will return the answer. Why we are returning? Because I know the answer is going to store in this vector answer. Okay, let's just start. So since we are starting node, okay, so you are currently here. Like if you say, let me create a graph. What is the graph of this? 2, 3, and 1, 4, and 3. This is the graph, and you are starting over here. So this is the start point, and you are not visited yet. So mark it as a visited and put the value into the answer. So answer is this. So wait 1 second. So let me erase this. I will create an answer over here. So answer is, put the answer 0 over here and mark it as a visited. So you are a starting point, you haven't visited yet. So mark it like is visited of node equal to true, since we haven't visited. So and put that node into answer. So how we are going to push, how we are going to put into a vector? So this is called pushback, and whatever node we have to push, it's 0. So we are at the 0th node, and we marked the 0th node to be true, that means it is visited. Now we will pushing that node to the answer, that means 0th node to the answer. Now we will go to every node, like how many nodes we have. And sorry, no, not nodes, we go to its neighbor node. We have three neighbor node, 2, 3, 4, 1. You can start, you can go to either of them, like 2, 3, and 4. So how do we find this neighbor node? In a question, in a adjacency list, in a adjacency list, we have given like this thing, what, 2, 3, 1. And what are the things we have? 0 and 0, 4. uh, 0 and 0, 4. This is the thing we have given. And you can, as you can see, and lot more there. I don't go, I will just explain the things what I want to explain you. Like this is the 0th index, 1, 2, and as you can see, 0 is connected to 3, 2, 3 and 4, 2, 3 and 4, 2, 3 and 4. Oh, sorry, 2, 3 and 1. Sorry. 0 is connected to 2, 3, and 1. As you can see, they are the neighbors, 2, 3, 1, and all of them are not visited yet. All of them are not visited. So we will go to each node, one by one. Let's say we are starting from 2 and go to 2, mark it visited, and go to its neighbor again to repeat the process. Let's say how. So we are at node this, so we are currently pointing to this. This is the node we are currently at, 0th node, and this is the neighbor node. We will go to each node and recursively call its neighbors. That's it. Your question is done. Like your solution is done. Like how we will go to, I will apply a for loop for every node. So it will be for int I equal to not, okay, I equal to 0, I is less than I plus plus, n is what? The size of, this is the adjacency list. What is this? This is adjacency of 2D array. So how we will do, how we'll get the size of this neighbor? We will do a, sorry, adj of node. What node represent? It is the index. So node dot size. We will get the size of neighbors. How many neighbors is connected to this node? Here it is 3. So we will get it adj of node dot size. Okay. Now you can create a variable called neighbor. Right? Or I don't know what's the spelling is this. Just neighbor. Okay, neighbor. What is the neighbor? How we will get neighbor? Adj node of I. So we will go one by one, like this one, then this. So they all are the neighbor of the current node. So this is the neighbor. Now what we will do, I'll just call it DFS2 again recursively and passing neighbor as a node. IGHR neighbor, and graph is as it is and is visited as it is and the answer as it is. That's it. We are done. Like you are passing fresh, like you can treat as a fresh this as a 2. Now you are at current node is 2. Now you'll go to its neighbor and treat as a current, this is the current, and go to its neighbor again and again until there is no neighbor, like 4, there is no neighbor, so you back again to the 2th node, and if you find again there is no node, so you'll back again to the 0th node. So you'll do the same thing, and I think the code is completed. I hope there is no mistake, I didn't forget anything. So let's try to run and see if it is running fine. I hope this run. Okay, we are getting a compiler error. So what it says is visited was not declared in the scope on the line 5 6. Okay, this is the 5 and the on. Okay, so I have done spelling mistake. Is the z tet? Let's compile again. Okay, we are getting segmentation fault dimension. Why we will get a segmentation fault? Because we are accessing some kind of node which is not accessible. Like segmentation fault. When we will get a segmentation fault, if you are this like 0, 1, 2, 3, this is the array of size 3. Sorry, it has a size 4. And if you try to access this one, like the fourth index, and the array does not have a fourth index, so you are trying to access it. Like if you try to print this, see out array of 4, you will get a segmentation because you are trying to access those location which is not located, which is not in the memory. So this is the segmentation fault, and we are doing the same, and we don't know where. So let's try to do the oh, sorry. Let's try to find the bug. Okay. So we are creating answer dot pushback. It's okay. Is validated node are correct? Like uh, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 node is created like 0 to 4. This is correct. Mm, to 0 to node size. Is node is like mm, node is connected correctly. I plus plus is we are missing something. Let's do one thing. Let's print that the thing is sorry, node. Okay, let's compile this. Your output is none. Time limit exceed. Mm, what I'm going to miss? I equal to 0 to I less than I plus plus. Okay, no problem here. Mhm. Time limit exceed. Why time limit exceed? If I'll do this thing, mm, auto IT, let's say NEIGHR neighbor TJ of node. If I'll do this thing and I'll comment this thing, let's see now if it is run or not. Again, I think this is something. I believe this. Sorry. I have to see if my neighbor is visited or not. Is visited of neighbor. If it is visited, like we have to check also na ki the node is visited or not. If it is visited, why we are visited again? So why we are printing again? So it is continuous in loop. Let's say uh, we have node this. 1 second, guys. Okay, so this is the graph 2, 3, and 4. Let's say I'm the starting node is this, so we will print this. This is the print. Okay, this is the output. So we have printed first this zeroth node. Now we will go to its neighbor. Now neighbor is 1 and go to neighbor and print this one. If we don't mark, like if it is already visited, you'll see this, its neighbor is 0 as well. Like your current node is this is not the current node. Now your current node is this, and you are at node 1, and if you try to find its neighbor is 0 as well, and we already have printed 0. And if you try to print this 0 and go to its neighbor, you are again come to the 0th node. So if you try to find its neighbor, then again 1 1 and so on, like 0 1 0 1. So that's why I think the time limit is there. So I have to check if it is visited of neighbor equal to false, then we will call the DFS2. See, now it's the your output is 02431 and the expected output is the same. So what I have do here is, like, this is the another way of iterating. You can do this the previous thing as well. Like you can start from like int I equal to 0, I is less than adj of node dot size I plus plus. Okay. Now if you do this thing, it is also correct. We are just not checking like is visited of neighbor is false or not. This is very important. If you don't do this, it will show you like time limit exceed. And if we try to submit this, let's see if it is running, submit it fine or not. Okay, all the test cases passed as you can see, and we are correct. Okay, so this is the DFS guys, and yeah, I hope you understood it very well. Let's do one question from uh, the sheet, and this is the very famous question, number of isolate. So let's go to the okay, number of isolate. I already have solved like most of the question from this sheet, and we are just going again. So you just read the question. 2 minutes. 142 is right now. So read the question 2 minutes. I will come back again. Okay. So 1 second, guys. Okay. What question says number of island given an m cross n um, 2D binary grid, which represents the map of the first island, and 0 is the water. Return the number of island. An island is surrounded by water and is formed by connecting adjacent land and so we have to count number of islands, I think. Okay, so let's go to the notepad. What we have to do, we have given a matrix, let's say, and this is the matrix we have given. 1 1 0 0 1 1 0 0 1 1 0 0 0. This is the matrix we have given. Let's say what is the size? 1 2 3 4 5. 1 2 3 4. So 4 cross 5 is the size. So we have to count. One represents land and 0 represents water. Okay, so we can move from vertically and horizontally. So this is the thing we have given. Okay, so we have to count number of islands. Island. Okay, so mm, let's take blue color. Where is the blue color? There is no blue color. Oh, there is blue color. Okay, so this is the water. As you can see, this is the water. This is the water, and this is the water. Okay, this is the water. This is the water, and this is the water. And how many number of lands we have? Lands I'm going to mark with yellow color. So this is the land we have, one land, and this is the another land, and this is the another land. We have three land in this matrix. I hope you understood this thing. First of all, you have to uh, you have to read the problem carefully. If you understand well, like I'm showing it in a graphical manner so that you can understand it better. Like they are connected in horizontally. Like you can't say this is also connected because they are diagonally. In the question, it is mentioned that if they are connected horizontally, they are horizontally connected, up and down or right and left, not diagonally. This is not the case. So why we can't include in this one island? Because they are connected in diagonally, so we don't include. As the question mentioned, we only want horizontal things. So let me erase this thing. How we are going to do that? Very simple, guys. You'll start from, let's say you will start from here and traverse like usually in a matrix. Like how you are going to print the matrix is like going through this, then going through this, index wise, like 0 1 2 3. This is the index. First of all, you will traverse all the rows, like uh, print all the rows, then go to second, then go to third. You will do traversal in the matrix in this way. Or you can start any of these, like you can, like, first of all print this column, then go to this column and this column. Doesn't matter. Let me erase. You you just know the traversal technique, nothing else. We will apply DFS in a while. How we are going to apply DFS? Let's say, let mark with index 0 1 2 3 and 4. I'm taking too much of time because it's starting phase. You have to, like, you have to take a pen and paper and do the dry run so that it will stick in your head and you are very comfortable and you will write the code in your own. So in a starting phase you have to give a lot of time. You have to practice, you have to dry run a lot of things, then you are able to do with your own. So the I'm just keeping this thing simple so that you can understand. Okay, so we will start from this node. This is the We will start from this cell. I will let it just I will start from this cell, and whenever we find one, we will apply DFS. I, I will repeat it again. Whenever we find one, I will apply DFS. Why? Whenever we find one, we will just say there is one island. So we will just create a number of island. It's not okay. Iceland equal to 0. Initially initialized with 0, and whenever we find through the traversal one come, so we will increment this with 1. So we will do number of Iceland plus plus whenever we find 1. So we have find 1. What we will do? we will apply DFS, and whenever we will apply DFS, what so when we will apply DFS, uh, so this is the starting point, what it neighbors. Now the neighbor definition is changed. Neighbor definition is changed. How? We can go to it's horizontally or it's vertically. This is the new definition of neighbors in this case. In the matrix, most probably the definition of the neighbors is like uh, you can go horizontally or vertically, or in some cases, and you can go diagonally as well. Okay, so you are at index, you are at here. Okay, now you have two neighbors, like you can go to here or you can go to here. So 0 represents water, so we have to make this as a water. So we will make it as a water, and we will go to its neighbor, which is this one. Now we will go to, we are currently over here, this this cell, and now we will go to its neighbors. So what are the neighbors? These are the neighbors, like this is the neighbor, this is the neighbor, this is the neighbor. Now we will try to find one, and as you can see there is no one. We already make this as a 0. This becomes water, and this is also becomes water. Since while visiting I'll uh, make visited or make this as a water, whenever we will see one. So as you can see there is no neighbor which has the value 1. Okay, so this becomes water, they both becomes water. So this becomes water 0, and this becomes water 0. Now we will go to the we will come back to the matrix traversal, and if you DFS is over here, like you'll make this 2 Iceland equal to water. So the DFS is over. Now you are come to the traversal. Now you are here, you see a 0 again, you see 0 again, that means water. You see 1. 1 means what we have to do first? We have to increase the number of Iceland to 2, 1 by 1. So previously it was 1, now it becomes 2. Now you start DFS traversal from this, treating as this is the starting index. This is the starting node. What it has neighbors? It has neighbors this and this, because we have to do horizontally or vertically. So we have two neighbors, and all the two neighbors are 0. So DFS and here. Okay. So this is just need this. Okay. Now we will come back to the traversal again. uh, 0 doesn't care, 0 don't care. We will find 1, so this is 1. Now whenever you find 1, you have to just increase the number of isolate by 1. So previously it was 2, now it became 3. Okay, now we will apply DFS, and this is the starting node. What its neighbors? This is the neighbor, this is the neighbor. Let me mark it with the green color. This is the neighbor, this is the neighbor, and this is the neighbor. Why this? Or this is also neighbor. Why this 4 has 4 neighbors? Because they are horizontally connected. Doesn't care about how we will get these neighbors, as now we will see it while coding. You just understand, we only have 4 neighbors now. These are the 4 neighbors, and they are connected via horizontally or vertically. You can't consider this as a neighbor, because they are connected to diagonally. So in the question this is not mentioned. As you can see, this is where it is. Okay, here it is, horizontally and vertically. Okay, so we have 4 neighbors, and we have to find one. So this is the one we have. You can, this two one, Let me use this color. This is the 2 which is 1. So we will mark first this is 0. This became water. Now we will go to this or this. You can go to either of them. Like let's say we will go first this and make it water and find its neighbor. Its neighbor is this neighbor is this, its neighbor is this. Let me use this color. Okay, its neighbor is this, and this. These are the four neighbors. But as you can see, this is marked 0, this is 0, this is 0, and only one is left. So we will go to this neighbor. This is the neighbor. Now make it 0, make it water, and find its neighbor. What are the neighbors? This is the neighbor, this is the neighbor, and this is these three all are neighbors. And as you can see, on them there are two water, so we don't consider it, and we will just go to this one and make it water. This became water, this became water already. Now find its neighbor are this and this. Both, all of them are 0, all of them are water. So we will backtrack, go back to this node. There is no neighbor left which has a value 1, so we'll go to again this thing and we'll go to again this, and as you can see there is 1. So we will go to this node and make it 0. This became 0, this became water. So this is the thing. Now DFS ends here because there is no neighbor for this node. For this node, one second. uh, let Okay, this is the current node, and if you try to find its neighbor, this is the neighbor, this is the neighbor, this is the neighbor, this is the neighbor, and as you can see all of them are water. So we will go back to the starting node, and for this node there is no node which is 1. So DFS ends here, and now we are at the matrix traversal. So we will go to every cell, and as you can see all of cells becomes 0. So we don't have, and at the end we get the number of isolate equal to 3. So what we have done so far, let me show you. Let me erase all the things, and okay, let me use this thing. So, so this is the starting matrix we have. Now what we are doing is, the concept is like, whenever you find one or the connected node, whatever the connected nodes we have, just make it water. This is the one, the connected nodes, all the connected nodes becomes water. This is the node, all the connected nodes become water because there are no uh, connected nodes, so this only becomes water. So this is the one, this is the second isolate, and we will get 3 this, and the connected node is this is also connected, this is also connected, this is also connected. So this is the one component we have, this is the one, this is the one. So we will get eventually 3 components, or you can say 3 isolate. That's it. So let's implement this. Okay, so uh, let's take the size of matrix, n equal to number of rows grid dot size int m equal to, let me check if it is recording or not. Hello, yes, it is recording. M equal to grid dot it's column, so 0 dot size. Okay, now here is the question, how we will find its neighbor. Let's say we are at I or j, I and j. We can go up, we can go right, we can go down, we can go left. So that means we have to plus one everything, like we have to jump only one, not two. So what is the change we get? Like If you go up, what change? Like uh, its row changes, like I minus 1 happens, sorry, and j as it is. Why minus 1? Because if you are at I, this is pointing to I, its previous bill is like I minus 1 and its next will be I plus 1. Okay, so this is the concept. Now if you go to right, okay, this is the color. If you go to right, this is the right, and what change? I change? No, I doesn't change. So I will remain same. What is changed? Like j over here, j plus 1 and j minus 1. Or you can just like write this I minus 1 or j, sorry, I plus 1, I plus 1, and you can write it like I this or j plus 1 this. You can understand any of them, like what is the coordinate of this? I plus 1 and j as it is, and for this I as it is and j minus 1. That's it. And if you notice, like here it is changes minus 1 or 0, it changes 0 1, and 1 it's changing 1 to 0, and 0 to minus 1. So these are the changes we have. So according to that, we will store it in a direction. Let's create a vector directions. What are those directions? Let's say 1 and 0. We will just write changes 0 and 1, minus 1 0, or 0 minus 1. I will remember in this format, like 1 0 0 1, minus 1 0, and 0 minus 1. This is for horizontal and vertical. Remember this. You can matlab, in a lot of question we are going to use this. So just remember, you have to create a vector of vector. It's a 2D vector, vector of vector, vector of vector. Int internally it has a size of 2 because we have only two coordinates, and the second it has a 4. Or you can use vector of pairs because it has a size 2, so we can use pairs as well. Whatever you want to use it, but just remember, like this 1 0 0 1 and minus 1 0 0 minus 1. Okay, so we will create a direction vector globally. We will create it globally, so we can use any of the function whenever we want to use. Okay, so we will create it like vector of vector. You can create just like pair, you can use pair as well. So we will name it as a directions. I don't think the spelling is correct. Directions. Okay. 1 0 0 1, then minus 1 0, and 0 minus 1. Uh, it's not the rule, like it's not the rule like you have to write in this way. You can use first this way and then this way and this. You can use in either of them. It doesn't matter. I'll just show you so that you can remember. It's easy to remember. I personally use this way to remember this thing. Okay, if you can't see, let me zoom it. There is setting and code editor, 20 pixel, 21 pixel. Okay, okay. That's good. Okay, so what we have done so far, we have just create two variables and m, where we are storing the matrix sizes, and we will just created our directions. Okay, now we will do traversal for int I equal to 0, I is less than n, I plus plus, and for int j equal to 0, we need two loops to traverse the matrix j is less than m j plus plus, and whenever we find if grid of I and j equal to what, what, since this is the character, so we have to use this, or whatever it says, I don't know, quotation or single quote or whatever. Okay, so we have to use this, and we have to check if it is 1. If it is 1, then we have to start from here and we do traversal, DFS traversal. What we have to pass I and j, since these two represents node. Previously in this question where it is question, there is only one node, 0. But in the combination of these two, I and j, they both are represent one node. So this is the location of that node. Like let's go to the this one. Okay, if we have this thing, this is the node, and this is the location I and j. I and j is the location we have. Okay, this we have to pass, and grid we have to pass. Why we are not using visited? Because visited we can use, like 1 and 0 is also, 0 is like we have already visited it, so we don't have to visit it, create the new matrix for that. You can create and it won't give you time limit exit, but this is the simplest way. Okay, not simplest, but it's slightly complex, but okay. And what else we have to pass? I think that's enough. Okay, and we have to create a variable called number of islands. Initially it is initialized with 0, and here we, whenever we find 1, we will just increase number of islands plus plus. Okay, after this happens, at last we will just return number of traversal, sorry, number of traversal, I'm sorry, island lengths. Okay, now we will create a function called DFS, and it would be void. It doesn't return anything. So DFS I represents uh, what it represents, row, sorry, and J represents column, and we will just copy this thing and paste it over here. Okay, now okay, so this is enough. These two both represents the node. Oh, then what is the next step? Uh, we have to mark this node as visited. So we will do this thing, like grid of I and j will become 1. Sorry, will become water. So it would be 0. Now what we will do, we will go to its neighbor. How we will go to its neighbor? For this is the thing we will use, like for auto direction equal to direction. Let me copy this thing. Okay, this is the new, or if you don't understand, if you can use, like you can apply two loops. You can do either of this. Let me write it for you. For int I equal to 0, I is less than, not, we cannot use I, so we will use row equal to 0. What we can use, anything, like let's say m and n. M equal to 0, m is less than 4 because it has a size 4. So m plus plus, for int n equal to 0 and n is less than, what is the size of every uh, inside vector? It's 2. So we will go to 2 and plus plus. You do the this thing, or I'm just using this thing because it's very simpler. dir represents, we will go to every inside vector, like dir, first dir will be pointing to this whole vector, not the single element, it's whole vector. Like first dir pointing to this vector, then it will go to this vector, then it will go to this vector. How we can access? We will just like this. We have to create new row, would be dir, we will use vector 0 plus the I. Why I am doing this thing? Let's say, uh, what is the directions we have? 1 0, 0 1, minus 1 0, and 0 minus 1. These are the four directions, and dir will just go one by one like this, dir. Okay. Now if you want to access this first element, then you have to treat it as like a vector. So dir of 0, it is name, like you can say. So dir 0 will gives you 1 this case. Okay, if you are at this say I and j, so you are at this, and if you want to go up, then what you have to do? I minus 1 you have to do, and j as it is. So this 1 or 0, where it can apply, like 1 and 0 means plus 1. So you have to go down. That means you have to plus 1 and j as it is. So this thing represents this. So what we are doing, we are taking the current row and current, this is the current row and current column. We are just adding plus 1 to the current row and putting j as it is. So we can go to check the down neighbor. This is the neighbor, and we just checking this down neighbor. And we have to do one more thing, like we have to check this, the coming new row or new column, it is valid or not. Let's say you are at this row or column, so this is I and j, and if you try to find out here, which is not a valid thing, like if you go to its left, this is the left, and if you do I as it is and j minus 1, then this, there is no cell. So we have to check it, if this row and column is valid or not. If it is valid, then we will check, otherwise we will don't check. How we will check? Like you have to just check, like if I is less than n, which is the size of grid, j is less than m, which is the size of this column of this grid, and we also check I is greater than 0 or j is greater than 0. So we have to check. So this is the new row, and new column will be dir of 0, sorry, 1 and j. Okay, now we will check if my this new row is valid or not. New row should be greater than or equal to 0. Agree? Then new column should also greater than or equal to 0, and new row should be less than grid dot size, and new column is less than grid of 0 dot size. This is the check we have to apply. Let me write it over here. Check is row and column is valid or not. After that, if it is valid, then we will go to its neighbor, and we also have to check if the grid of new row, new column equal to 1. If it is 1, then we have to go to the node neighbor. So it would be new row, new column, grid as it is, and that's it. I think we are done. Okay, let's try to run this and see if it is correct or not. Okay, so what is spelling mistake again? Grid, GRID. Okay, number of islands. Spellings are mis copy, paste, paste, run. All the test cases pass currently. Let me submit this, and we will mark it as we have solved this. And I think that's enough for today. As you can see, this is accepted, and yeah, we will do the other questions in the next or video. They are very simple. Like you have to understand deeply DFS. You have like you just go DFS algorithm, explain. You can just follow any of documentation. Like they have great documentation. You can use like visual mode to understand how it's working. Because if you can't use a pen and paper, then I think you don't understand. Use pen and paper. Try to solve 2 to 3 questions. Try to solve 2 to 3 questions. Dry run that graph and print that DFS so that that algorithm stick to your head. And we are surely do this uh, 2 to 3 question, whatever the question mentioned in this list. We are going to do this, and I think we will do in this in one video, because they are just using DFS and you have to understand what DFS is doing. I'm just putting the code, copy and pasting. We will understand once more so that you can understand it better. Okay, so see you guys in the next video. Thank you for watching.